Yeah, yeah.
Oh. We'll eventually, those of you that had GeoGebra, we'll eventually get to using the GeoGebra stuff to kind of expedite some of the things that we do here. But we need to be able to do this because the end of course exam often asks you to do this. And I know you guys have taken Algebra 1, and it would be really nice if you had taken Algebra 2 by the time we take the end of course exam in geometry. Some schools do that, about half of them do that, half of them don't. Half of them do it the way we do it. But the end of course exam a lot of times has questions on there that has Algebra 1 stuff on it that you saw last year, but you're really not all that great at it, just seeing it one time. Okay, so if you would have had Algebra 2, then you use it a lot more than what we do in this class, and you would be maybe a little bit more successful on the end of course exam. So, that being said, if you had Algebra 2 before this class, this stuff we could kind of fly through, and it would not be very difficult to kind of deal with. Okay, but it would be just very common algebra to you at that point. So we will slow things down a little bit today. We'll probably only get through one problem because it's a very long problem.
Do the whole class period?
Yeah. Sorry.
Is there homework tonight?
We'll see.
No, there's not. My birthday is March 11th, Mr. Fay. I turned 15.
Mr.
Okay.
Fay, 19 days.
So I want to plot those points. Now I want to go through, let's find the midpoint of AB. And if you remember your midpoint formulas,
AB
yep,
is a 2, 4.
how'd you find that?
I'm just looking at it, Mr. Fay.
Okay, well don't do it that way. Because the thing about this, and this is the way I teach, I know what the end of course exam kind of looks like. I know what the ACT kind of looks like. And if we go just by looks all the time, then this class, the learning would be so much easier. But they know that that's what you want to do. As an author of a test, they know that you want to look at something and say, yep, 2, 4. Okay? So they will provide you eventually with maybe points. Oh, let me move around here. They might provide you with a point like that, and a point like that, and maybe they'll even mess around with you and say that your x-axis and your y-axis are not the same scale, and then ask you the midpoint, and it's really hard to kind of look at it and ballpark where the midpoint is, right? Looks like maybe 2, 3.75 or 3.8 or 3.78. We don't know, right? And so they do that to you. They know that you want to find that shortcut. A lot of times they're going to provide you endpoints that you can't do that with. You have to revert back to our formulas. The formulas will never let you down. Okay, so hopefully we come accustomed to that. So if I take A and B, find the midpoint, we add the x's of the endpoints. So 4 plus 0 gives me 4, and then divide by 2. Okay, so I'm going to get 4 plus 0 divided by 2 is 2. And then I'm going to do the same thing with my y. So 6 plus 2 is 8. Divided by 2 gives me 4. So it does verify what you found, which is good. So hopefully we're able to do both. Okay, maybe visually have an estimation. Hey, it looks like it's 2, 4. Now let's go through the math and actually verify that it is indeed 2, 4. So now that we have that, I want you guys to I just applied it in your picture, but then go back through, and now I want you to find the slope of AB. And again, you could count rise over run, correct?
Yes.
Okay. But let's go in.
Is it 1?
Yeah, it is 1. Well, let's go through the algebra to make sure that is maintained, because on the end of course exam, they might give you, again, endpoints that aren't really conducive to you just counting rise over run.
Did you say conducive?
Yeah.
I figure it out, but give me the exact definition, please.
Please, he's recording everything you said.
Ooh.
Our voice is going to be on YouTube.
Huh?
Our voice is gonna be on YouTube.
A lot of times they are, but you can't really. It's
I'm gonna
muffled. You
say-
can't
I'm
really
gonna
hear
say
it.
cuss
So
words,
weird.
so you can't. I'm gonna say cuss words so you can't like upload it.
You would get sent out like off.
Conclusive, is that what you said? What word?
Conducive.
That's not a word. Wait, was it C? C or N? Okay.
C-O-N-D-U-C-I-V-E.
Conducive, making a certain situation or outcome likely or possible. I don't remember how you use it in this sentence.
I don't either, but I use it right. So slope AB. Subtract your y's up top, so 6 minus 2, and subtract your x's on the bottom, 4 minus 0. So 4 or 4, right? And that gives me 1. Okay? Now that slope of 1 is nice, but for what we're going to try to do here, it's not the kind of end-all slope that we want. Okay? What our goal here is, why I had you find the midpoint D, and why I'm having you find that slope AB, is because there is a line that exists here. Would you guys agree that there's a line here that might be perpendicular through D and then perpendicular to the line AB or the line segment AB?
Yeah.
Yeah. We're trying to find the equation of that line. Okay? That's the perpendicular bisector, right? That I just drew in there?
Yeah.
We want to find the equation of that. Okay? Well, that perpendicular bisector is related in regards to slope to the slope of AB, right?
Yeah.
The slope of AB is 1. The slope of a line perpendicular to AB, okay? So any line perpendicular to
Can
AB
you write this down?
has slope equal to what?
The reciprocal.
The reciprocal, so what's the reciprocal of 1?
-1.
Careful.
1 over 0. 0 over 1.
You were right by saying the reciprocal of 1 is 1. Because that's 1, right, as a fraction?
Yeah.
Reciprocal is
Okay.
numerator and denominator switched, right?
Yeah.
So it doesn't provide me anything new. But then when we talk about lines that are perpendicular, we had the additional phrase that we had to have opposite sign reciprocals.
Negative.
So now that's where that negative comes in. We'll talk about.
Okay.
Okay. So obviously, a lot of times, if I got a whole number, an integer as a slope, a lot of times we don't obviously put that denominator of 1 down there. So that's really the slope that we're interested in. Okay. This point here, 2, 4. Would you agree that's on the black line that I drew up there?
Yes.
Okay. And we now know the black line up there is going to have a slope that is equal to -1, right?
That does.
Okay. Well, the way I drew it, it doesn't, but once we accurately draw it, it will.
Okay.
When you have a point and you have a slope, you have enough information to construct a line or an equation of a line that has that point and has that slope. Okay. So let's kind of discuss what equations really are for us. So the midpoint was 2, 4. The slope we're looking for is -1. Okay. That is information that is going to provide us the perpendicular bisector of line AB, right? Or line segment AB. You guys agree with that?
Yes.
Okay.
Wait, is this all part of the same problem?
Yes. A equation, don't write this down, just kind of watch. If I have an equation, y equals 2x plus 3, okay? We have an idea in our mind what that should look like, right?
Yes.
Going back from algebra 1, should look like y-intercept of 3, rise of 2, up 1, and that's my line, right?
Yes.
But what that really is, what a line is a collection of a lot of ordered pairs, right?
Yeah.
How many ordered pairs?
Infinity.
Infinite, okay? So I've got all these ordered pairs, okay? And we're interested in a lot of times in all of those ordered pairs, okay? And maybe listing them. Well, if I had a list of infinite objects and that was my goal to write them all down, am I going to be able to do that?
No.
No, okay? So, this is a tool, this is a rule that provides you a manner of finding all those infinite or writing all those infinite ordered pairs at once. Okay? Because now choose x. Choose a value for x, whatever you want it to be.
Negative 100.
Okay, 7. 2 times 7 is 14, right?
Yeah.
Plus 3 is 17, right? Okay, so I got the point 7 comma 17 should be an ordered pair out of that infinite set that we wanted to write down. Okay? So it gives you the ability to kind of reference any one of the ordered pairs that exist on that line, right? Well, when we want to create a line, we want to create this equation. We now have some components of the line that's going to allow us to do that. We know that 2, when I create an equation here for this perpendicular bisector, we know that better be on there. Okay? Because when I plug 2 in, I better get a 4 out, right? That's one of those infinite ordered pairs that exist on that black line up there. 2 4s on there, right?
Yeah.
So we can use that point to help us develop the equation of the line. In the slope here, we know the relationship that this line has to have in regards to that line AB, so that slope is what we're going to use. Okay? Whenever you're interested in finding the equation of a line, this formula
No.
ends up being your best friend.
You want to start that
Okay,
out?
I would write that down. We did this a couple days ago. One of the questions in Math Excel dealt with, they gave you two triangles that looked, just kind of jog your memory a little bit here. Gave you 2 triangles that looked like this, and I think it was side, side, side that they ended up being kind of congruent. But they asked you to be able to find that ordered pair in order to force these triangles to be congruent, to determine that. And by doing this, we came up with an equation of that line and an equation of that line. If you remember this, I think this was called point C there that they're interested in. But we had to write equations to do that problem. And this is just a different part of geometry which asks us to use the same type of algebra to analyze something. We have to be able to write these equations. This is referred to as point, okay, because that represents a point,
Slope form.
and that is your slope. So we call this point slope form.
Oh!
Okay. So you've seen this before. You've done this before in Algebra 1. Okay. Now, like I said, if you would have Algebra 2 before this class, you would have done this so much more because you do this again in Algebra 2. You do this again in college algebra. My first week, 2 weeks of college algebra, we do this again. All right. That's the kind of thing about mathematics. A lot of times is that you see something 9th grade, you see it again 10th grade, you see it again 11th grade, 12th grade. But we start to dig into it a little bit deeper each year. This thing right here is going to be the number one thing you want to turn to when you're coming up with the equation of a line. Okay. The nice thing about it is the things I need are a point on the line and the slope of the line you're looking for. So this information right here, 2 4 is a point on the line, right? It's a point on the line that I'm looking for. So I'm gonna put y1 here. This here is your y1. That's your x1. So I'm gonna go y minus 4 m. Well, we're trying to find the slope, or we need the slope of the line that's perpendicular to AB. Well, we found it. That was -1. And x minus x1, so 2. And that is the equation of a line. Now, it's not in a great format for us to plot in graph like you did maybe last year. You guys remember y equals mx plus b?
The M
Yeah.
Is that from up there?
Yeah, it's that's when we did the work to find the slope of AB and then look at its opposite side. So you guys talked about y equals mx plus b last year, right?
Yes.
That's probably the one you spent most of the time working with instead of this one. However, they are the exact same thing.
So we can
Okay.
solve it.
So what we want to do is we want to take this thing and let's just solve it for y. So
Don't you need?
you've got options here. You can distribute this first and then move over the 4. That's kind of the way I always do it. Or you can move over the 4 first and then distribute. Doesn't really matter.
Distribute first. So -1x plus 2?
And now you're gonna move that 4 over. So what's that give you?
6.
Yep. Negative x plus 6. So that right there is a rule that provides you the infinite number of points that exist on that black line, right? To make sure that I've done this correctly, what is one of the points that you know should be on that black line?
2 4.
2 4. Okay? I'm the person that, I kind of know how long this is going to take, how long this problem's going to be, and it's going to be pretty lengthy. I would hate that I make a mistake here, and then I do basically, we get to this point, we've got like maybe a fourth of the work done for this problem. I would hate to make a mistake here and then continue to work through the rest of the problem and not know that I made a mistake, right? Because then the rest, everything after this mistake would be wrong, okay? So, what I'm going to do is I'm going to take x to be 2. Plug it in here. Negative 2 plus 6 gives you what?
4.
4. So I use that point to plug back in here to make sure that the information that we have up here is reflected here. I should be able to find the all the points that are on that black line should show up in that equation. Does that make sense?
Yeah.
All right, so what we just found is the equation of a perpendicular bisector. So the equation, I'm going to write this up here, the equation of perpendicular bisector to segment AB is y equals negative x plus 6. Okay? Now, how do you guys plot? You remember what y equals mx plus b. What's that plus 6 tell me?
The y-intercept.
That's the y-intercept. So that's where we cross our y-axis, right?
Yeah.
So
Wait, I can't see them.
Oh,
Alright, you're good.
So when I go and I'm going to find 6, so 6 is there, right?
Yeah.
And now the slope was down 1 to the right 1, right?
Well, I thought it was down 1, right 6. Since
No, your slope is always the coefficient for your x. So my coefficient is negative 1 x. So we write that in fraction form as negative 1 over 1 times x. So it's your rise, and that's your run.
since it's negative, you go down 1 and right 1.
Yep. So this one tells you up or down. Top one tells you up or down. If it's negative, you go down. The bottom one tells you left or right. If it's negative, you go left. So this down 1, right 1. So if I go down 1 from here, and then so it'd be
down
about
2.
right there,
Yeah.
and then over 1, put it there, right?
Yeah.
And then go down 1 more and over 1. You get a point there. If I go down 1, over 1,
Yeah.
down 1, over 1. Okay. So I should end up with maybe a point there. I should have, like I said, a point there. Should have a point, I think. Nope, should be that one. Okay.
Wait, what?
Not G. G shouldn't be in there.
Yeah.
So when I connect those points that we've used for determining this graph, that line right there should go through D, the midpoint, right? Because that's a point that we use to create the equation. But it is also, because you use the opposite sign reciprocal for its slope, it should also be perpendicular, right?
Mm-hmm.
And if I ask it to show that angle, it is perpendicular, right?
Yeah.
So what we just found is the perpendicular bisector of AB. All right, now I'm going to do it this way, just because this will allow me to change things here eventually. I don't know what that's all about though. Perpendicular bisector, and I want to do it between A and B. All right, so that's what we came up with, right? And look up here, and GeoGebra will allow us to, once I put that in there, once I form fit that in there, because it has that kind of generic tool for us to really quickly find the perpendicular bisector. Does it give us the same equation we came up with by hand?
Yeah.
Yeah. Okay. When we do that, okay, think about what just happened. Think about what we talked about, or what we've talked about, I guess, the last couple days. If I just remove those two segments right there, we found the perpendicular bisector of that red segment, right?
Yeah.
Didn't we talk about on Wednesday, if I have that point, and let's just call it point
E.
P,
FP.
let's call it P1.
Prophase 1.
Actually, let's call it P sub 1. Okay? You should call it PS might as well. But anywhere that P is, okay, what is it going to be the same distance away from?
A and B.
A and B. Good. Okay? That's what we talked about the other day. Any point on the perpendicular bisector is going to be equidistant from the endpoints of the segment that's getting bisected, right? And A and B are the endpoints of that segment getting bisected. So I'm going to keep this point P here. Don't worry about graphing point P, but I'll keep that on there for what we're going to do here in a little bit. You guys should be, you still have that triangle there in front of you, right? My hopes are is that now you drew in what roughly, drawing all this stuff by hand, you're going to not really be good at it or great. Your picture isn't going to be 100% accurate. But my hopes are you kind of drew in what might look like the perpendicular bisector, right? Okay. I would maybe put an arrow on that and say, hey, that's the equation y equals negative x plus 6. I'm going to hide all that stuff, okay? Just because it gets really cluttered in trying to explain to you what we're doing next. But really what happens, if you're able to do that, if you're able to find the perpendicular bisector of AB and find that equation, then you're kind of home free on the rest of this problem, because all we do is that exact same procedure again, but now instead of looking at AB, let's look at maybe segment AC. We'll find the midpoint of segment AC, we'll find the slope of AC, and then we'll write an equation for the line perpendicular to AC. Does that make sense?
Yeah.
So go through, find the midpoint of A to C. We're going to find
If you
the...
wanted to find the slope, could you just count
You could.
like up?
Yep. And let me talk about that for a moment, because it's similar to what at the beginning of class when we first did the slope, and
Forget my name.
no, Blaze said that he was going to look at this and say 2, 4, right? Okay. Just by looking at it's fine, and you're saying, well, if I want to find a slope of AC, I'm going to go down 1, 2, 3, 4 over 1, right?
Yeah.
So down 4 to the right 1, so there's my slope. But what happens, if you're looking at this, obviously I went down by 2's, right?
Yeah.
So I really went 2, 4, 6, down 6, and over 2, right?
Mm-hmm.
Okay. But what if they gave me points like that?
Well, then you couldn't.
I couldn't do that, right?
No.
So I'm always going to, in class, kind of use the formula, because the formula is always going to be the go-to thing when you can't count, when you can't use the visual recognition to tell me what the slopes are. So I want to just get comfortable with doing that. So the slope of AC, so it's y2 minus y1 over x2 minus x1, right?
Yeah.
All right. So take a minute, find those two things.
The slope, what's
Slope and the midpoint
AC?
of AC, yep.
So wait, so would it be 4 minus 6 on the top?
Doing the slope?
Yeah. I don't know.
So, well, your x's are 4 and 6, so that should be on the bottom. Because A, what is A? What's A's ordered pair? 4, 6?
Yes.
And C is 6, negative 2?
Yeah.
Alright. So the formula for slope is y2 minus y1, right?
Yeah.
So 6 minus negative 2. And then x2 minus x1, so it's going to be 4 minus 6 on the bottom. Go ahead and do that. This becomes addition now, so we get 8 over what? Negative 2?
Yeah.
It's going to be negative 4. So slope of AC is negative 4.
Yeah.
So what is the slope of a line perpendicular to AC?
4.
4. Or regular 4, I guess.
Slope of line. Careful.
1 over 4.
Okay, so this is negative 4 over 1, right?
Yeah.
We always want the reciprocal, so the reciprocal becomes 1 over 4. Okay? Then we want the opposite sign, correct? So this was negative. So when I write it this way, it's positive, so they are opposite signs. That's the slope. That's the m
So that's
that we're going to use for our equation. Okay? Those two steps, finding slope, I guess you're going to find midpoint yet, but the steps of finding a midpoint, finding the slope, and all these problems is going to be the same.
so you just flip them.
And then change the sign.
Okay.
Doing the midpoint, x1, x2, add those together, so your 10 divided by 2 gives me 5. And then 6 plus negative 2 gives me 4, divided by 2 gives me 2, right? So 5 comma 2.
You forgot your comma. Oh, it's just lower.
So 5 comma 2. That's my x1, y1 that we're going to use. And 1/4 is the slope that we're going to use. Inside, y minus y1 equals m times x minus x1. Okay. Obviously, you're seeing that there's a lot of work here. I mean, if I could make this less work for you guys, I definitely would. Okay. I don't like doing as much work as you guys are this much work any more than what you do. Does that make sense? It's just that there's no way around this stuff. If our goal is to be successful, then of course you can.
So would it be y minus 2 equals -4?
Yeah.
And then x minus.
Not using because this is the slope we're going to use.
Oh, I thought we were using -4 still.
This slope here, the -4 is the slope of that line right there, right?
Yeah.
We want to find the equation of the line perpendicular to it.
So that's why we switched it.
So that's why we switched. That's why I found that opposite sign
So
reciprocal.
it equal 1/4, and then x minus 5.
Faith, did you have a question? You good? Okay. So that is the rule. That is the equation. Now it's not in a really nice format for what we want to do next. Okay, and that's why in the last one we put it in a y equals mx plus b format. Okay. So
Now we have to distribute fraction.
distribute the fraction. So when I do that, 1/4 times x is just
1/4 x.
1/4 x. And now 1/4 times 5, that's a fraction times a fraction, right?
It'd be 1 and 1/4.
Okay, that's okay. But mixed numbers for anything that we do in high
that was
school
right.
or beyond, yeah.
Oh.
But anything that you do in math classes from, when do you talk about mixed numbers? Like 5th grade, 6th grade?
I don't know.
All right.
I never liked them.
Yeah, the week that you learn them, that was the only week that you're ever going to use them because they're not beneficial in our algebra.
I hated them.
Okay, so when we look at 1/4 times 5, we go 1 times the -5,
Oh yeah.
gives me -5, and then we'll take the denominator of 4 times that denominator of 1, and it gives me 4. But you said that's 1 1/4, right?
Yeah.
That's what that says. That's just that's what
Oh,
we're
so
called.
that's
That's
still
it.
gonna cross that 1 and like 0.25.
I will be careful, okay? Because we haven't solved for y yet. So when I solve for y, I add 2 to both sides, right?
Yeah.
So you get 1/4 x. I got -5. I'm going to write it this way. -5/4 plus 2. Now, the 5/4, let's look at this way. The 1/4 x, that's a variable term, right?
Yeah.
Everything else does not have a variable. Variable means change, right?
Yeah.
Okay, so that 1/4 x is the part of this thing that's going to change to create that list of infinite ordered pairs eventually. So that's our variable component. These two things don't change. So what's the word algebraically for things that don't change?
I don't know. I
Starts
guess
with C.
Control.
No.
Counter.
So would it be?
Close.
So would it be -7
Constant.
over 5?
Constant.
Okay.
Careful. You're right.
Megan told me.
Oh,
answer, so.
Good job, baby. So these are, we'll get to what you're saying. These are constants, okay? And the reason I talk about that is because they are like terms, okay? Variable terms you add together if they have the same exponent. So 1/4 x plus maybe something else that has an x to the first, you would add those together. But -5/4 plus 2 are constants that are like terms. You want to add those together. So how do I add 2 fractions together? What do I need?
You're gonna like times it by 4 on the bottom and then makes it 4.
Oh, you need.
You're gonna make it 4
greatest
on the bottom,
common
right?
Yeah,
denominator.
make it 4 and then make
Or
it
a factor or something like
Okay.
that.
I want to create a common denominator.
Yeah.
Okay. And between these two numbers, that common denominator is going to be what?
4.
4. Okay. So what's this top have to become?
10.
8.
8.
No, not Sean Carter.
Okay.
Five
Because
not
this was
going to
2 on
8.
the bottom, right?
5 don't go to. Oh, wait.
Okay.
I
This
thought
it was 5 over. No, not 5. It was what do we have there?
5
It was 2. Sorry. We had 2 there. Okay. And we wanted to rewrite 2 so it has a denominator of 4. So we're going to add it together with this thing. Well, if I multiply this denominator here, 2 over 1, multiply that by 4 to get that, right? So I multiply the top 2 by 4 as well to get that. 8/4, is that still the 2 here?
I don't know. Yeah.
What's 8 divided by 4?
I'm lost.
What's 8 divided by 4?
8 out of 2.
2. Okay? So all I'm doing is I'm taking this 2 right there, and I want to rewrite it as a fraction so I can add it with this thing. So it's 2 over 1. So that 1 needs to become a 4. So the top becomes an 8. So that it's still 2, but now I can add the numerators, right? When you add the numerators, negative 5 plus 8, what's negative 5 plus 8?
3.
3. So you have 1/4 x plus 3/4. That's the equation then of that green line that we were looking for. All right, so I'm going to put in the midpoint. Okay, and we said that should have been, oh, not that. I don't know why it's not working. All right, midpoint ACE, which we said was 5.2, right? That math is
Correct.
correct. When I put in, maybe I just type in y equals 3/4 x, or sorry, 1/4 x, 1/4 x. So writing in the equation here of the line we just developed, plus then
Plus 3/4.
3/4, and it does go through E, right? Does it look like it's perpendicular?
Sure.
Yeah. Okay, and if I go through and obviously
No.
use the angle tool,
Oh yeah, right there.
I need a third point, so that point there. If I use that angle tool, A to E to F is 90 degrees. Okay, so that is in fact the perpendicular bisector. All right. So a lot of stuff so far, right?
Yeah.
And I apologize for this,
It's okay.
but we're not done. Okay? Because what we're interested in, think about this. If I've got that point P1 up there, and you told me P1 was the same distance from A to B no matter where P1 went, right?
Yeah.
Okay.
Oh, now we need BC.
Right. So now if I've got another point, let's say that we found this point, let's call it P2. Okay. Is P2 going to be Is P2 going to be the same distance from A and C, no matter where I put it?
Yeah.
Is that all right with everybody?
Yeah.
Okay, so if that's the case, put these lines back together. Start sliding P1 somewhere. Start sliding P2 somewhere.
Oh,
What's
they're
eventually going to happen to
they're gonna
P1,
intersect.
P2?
They're gonna intersect.
They're gonna be the
Yeah,
same.
they're gonna cross somewhere, right? They're going to be shared. That point is common for those two lines. We call it a point of concurrency.
So when we do BC, there's probably gonna be one where they all three connect.
Okay, so if we did B, now I'm gonna kind of free up some of the work for us because Carter's saying, well, let's find the perpendicular bisector of BC. So if I do everything right, find the perpendicular bisector of BC. Now GeoGebra does this for us real quick, right? Does it go through that point?
Yeah, it does.
Yes. Okay. So that logic means that as long as I just do 2 of these perpendicular bisectors, the third one should always fit through the intersection of the first 2. Does that make sense?
Yeah.
So you only ever have to do this twice for any triangle that we're coming across. But what we want to do is we want to see that one point. We want to see what is that point in which those 2 lines cross. Okay? So just kind of cleaning things up here and getting us to remember what we've already done in past courses. If I were to give you that picture right there in Algebra 1, and I told you the equations of the 2 lines were y equals negative x plus 6 and y equals 1/4 x plus 3/4, do you remember what you did in the concept of systems of equations? Hey, what's going on? That, 16.
What's that?
Systems of equations that you were able to work through and find that point. And we've done this before this year. We've done it a lot this year, actually. If I've got y equals negative x plus 6, and I've also got y equals 1/4 x plus 3/4,
Are we write this down?
I would. This is the rest of the problem.
Oh, so now we're finding BC.
We're finding where those 2 lines intersect. We're finding where the perpendicular bisectors
I know
intersect
what
one
you
another.
do.
Okay. What do I do?
Set them equal to each other.
So what equals each other?
The y's.
Those two.
Okay, so these y's are the same, right?
Yeah, so just
So, however you did it. Alright.
Oh.
Those two things have to be equal, right?
Yeah.
So I'm going to take negative x plus 6 is equal to 1/4 x plus 3/4. We've done this year, right? We've done the substitution technique for
Why'd you
systems of
get rid
equations.
the lines?
Huh?
You just canceled out.
Because these y's are the same.
Oh, we're gonna find X.
If the two lines intersect, that means where they intersect, the y values have to be the same, right? If I look at this point right there, would you agree that the y value of that point is on this line right here, and it's also on that line right there? Okay. So what we're saying then, when these lines intersect, if they do, these y's are going to be the same.
Alright.
So then these are the rules that help us find those y's when we know an x, right? So these two things should be the same. Now we got this equation. What's nice with that equation?
It's easy.
Maybe. But it's got one variable, right?
Oh yeah.
Okay. Which makes it the easy route. It makes it easier than what it could be. But there are fractions in there, right?
yeah.
What can I do to get rid of all those fractions first?
Times by 4.
Times everything by 4. Okay? So take the negative x, becomes negative 4x. Take the 6, becomes 24. Take the 1/4,
X.
becomes 1x. 3/4 becomes
3.
3, right? Okay. Is that equation a little bit easier to solve than what we started with?
Yeah.
What did you do?
We wanted to get rid of fractions, so I multiplied everything by the
Okay.
least common denominator.
We're gonna get a
Or-
decimal.
Huh?
We're gonna get a decimal.
We might.
Okay.
Okay. But we're not going to write it as a decimal. We're going to write it as a fraction. Okay. I'm going to add 4x to both sides. I get 5x. I'm going to subtract 3 from both sides to get 21, right?
Yeah.
X now is 21 over 5.
Yes.
Okay. What you're saying as a decimal would be, how many times does 5 go into 21?
4.
4. And you're left with 1/5, right?
Yeah.
So what's 1/5 as a decimal?
1.5.
0.2. So this is actually 4.2. Okay? Leave it as a fraction because it's going to actually probably be pretty rare that we get really nice numbers like 4.2.
Or
Okay?
you can put that-
Last class we got a number of 135 over 19. Okay?
Would you put it as
So it's really not nice.
4 1 over 5?
Huh?
Would you have like mixed numbers?
Yeah, you could write it as a mixed number, but for the things that we're going to do next, we never use algebra with mixed numbers. Because the only thing we can do, like if I ask you to double that, or not say double, let's say multiply that by 2.5.
Yeah, you multiply everything by 2 and then everything by half.
Yeah, but what's 4.5?
Well, no, you
what's
just
four?
change it back
What's
into
4 1/5 times a half? That's hard
Just
to do,
change it
right?
back into a fraction.
Right. So you leave it as 21/5 times 5 halves,
Yeah.
and that's a lot easier to do. So improper fractions, even though they got that ugly name of improper fractions, they're actually the ones that are most useful to us. So x is 21/5. Do I have the ability to take that x and plug it back in here to find the y?
You
Yeah.
do.
Okay, so y then is equal to negative 21/5 plus 6. How do I add fractions?
Common denominator.
Common denominator. What would my common denominator here be?
30.
Careful.
There's a littler one, but I don't want to use
It
it.
want to be 30.
Wait, wouldn't it be y?
You're right. You want to make this 30,
Yeah.
but the common denominator is going to be.
15. Alright, good.
Why'd
What's
you
that?
put
What's
negative?
that? Well, what is the Okay, here's the thing. If you guys can't figure out the common denominator,
It's
take
5.
all your denominators, take every denominator up there, and multiply them together.
I thought we were talking about the numerators.
5.
Well, then what was that numerator if I was talking about
Five.
numerators?
5. Never mind.
So 5.
5.
So multiply all together, I get 5, right? So I want to make this 1 of 5. How do I make that 1 of 5?
Multiply by 5.
Multiply by 5. Now, how do I make this number adjust the same?
Multiply by 5.
Multiply by 5. What did I just really multiply by?
5.
5 over 5,
5 over 5. Yeah.
which is
A fraction.
What fraction? 1.
a fraction of 1. Good, okay? So,
So you want
6 times 5 becomes
30.
30, like you were saying, right?
Yeah.
So 30 over 5. Is that still plus 6?
It is.
Wait,
So now-
wait, you can make that a whole number. 30 divided by 5.
Yeah, but then we get back to this here. And so if I make that back to 6, then I'm adding that to a fraction again. So you just undid what we did. We don't want to do that.
Wait, we haven't added the fractions yet?
No. That's why we had to change that to a common denominator.
Okay, that makes
What's
sense.
negative 21 plus 30?
9 over 5.
9. So I get 9 over 5, and that's my y value. So when I plot 21 over 5, comma 9 over 5, That should be that point of intersection. Okay? So let's plot that. If I go 21/5, comma 9/5, it's that point right there, right? And that is the point that we are interested in. Okay? Throughout the entire problem. We started with this triangle, right?
Yeah.
We found those perpendicular bisectors, right? We found the equation of those perpendicular bisectors. We said those equations equal each other. We solved for x. Take that x, plug it back into one of the equations. Found y.
Wait, so we just found
That gave the ordered pair for point F right there.
Okay.
That's what this whole problem was about, is finding that ordered pair. Because now think about this. Think about this. Go ahead. What's your question?
Oh,
We're out of time.
are we gonna go over another one of these on Monday?
Yeah.
Oh,
Whoa, Carter!
Alright, here's the question. That point should be the same distance from F to, I think this was B, right?
Yeah.
A and C. You guys told me that any point on this line was equidistant from A and B, right?
Yeah.
So we should have the fact that FB should then equal F to A, right?
Yeah.
Okay? Well, don't we know that any point on this line is going to be equidistant from B and C?
Yeah.
So we have the idea that FB should equal FC, right?
Yeah.
What's that tell me? If FB equals FA, but FB is equal to FC, does it tell me that FA, FB, and FC are all the same thing?
They are.
Okay, so this point right here, this point, we have a name for it. It's called the circumcenter. Okay? Write that down. Circumcenter. What's circum mean?
Center.
Circle.
Circle. Circumference means circles, right? It talks about circles, right?
Yeah.
So when I say circumvent, that means to go around something, right?
Yeah.
It's a circle. Okay? So circum means circle. Center means center, right? Okay? What this means is this point F. It is the point that I can put a circle around F and take that circle. I get the right tool here.
Mr. Fed.
I should be able to go at F, make a circle that starts at F and goes through B or A or C. But if I go through any of those points, what does that circle do?
Touches each point.
Goes through all of them. Every single triangle you come across has a circle that can go through all 3 points. That's how you find the center of that circle. Okay? That circle is referred to as the circumscribed
Right.
circle. What's circum mean?
Circle.
Circle.
Oh my god.
Circum means circle, right?
Yeah.
What's scribe mean?
Center.
Written down.
Written down.
Okay.
Okay? So it's the circle that's written down. It's the circle that's drawn, and the geometric concept is that it goes around and touches all 3 vertices of the triangle. Every single triangle has that circle. Okay? And we're interested in being able to find it for certain things. We'll talk about on Monday, maybe an application of being able to find that circumcenter and why it would be useful for us. Okay? And I'm going to try to record next period too, but there's this example will be online, example from 4th period's online, and the 7th period's example will be online. So you got a couple of these things to look at. No homework this evening.
I think I say homework.
What's going on?
Who's this dude?